All right, go time. Let's see, since I just told, don't distract him, don't talk. Why do you have her water bottle?
I had a little bit.
Stop it. Now is not the time to share water bottles. Now is not the time. Too many germs. Okay, I just told you what a rhombus is, like 10 minutes ago. Can you tell me what a rhombus is? All the sides are equal, okay? We don't need to know anything about angles. It is a parallelogram with 4 congruent sides, okay? So a rhombus usually looks, you might call it a diamond, maybe? Kind of looks like a diamond, right? 4 congruent sides. Now, it can also look like this, 4 congruent sides, okay? But it doesn't have to look like a square. It doesn't have to be a square. It can have different angles, but 4 congruent sides, okay? What's a rectangle? 4 congruent angles. It is a quadrilateral, 4 sides with 4 congruent angles. So if it is a rectangle, those 4 congruent angles, because it has to add up to 360 if it's a quadrilateral, right? So 4 congruent angles have to be what measure? 90, okay? A rectangle is always going to have 4 right angles, okay? And maybe you just want to write that instead because the congruent angles will be right angles. So a parallelogram with 4 congruent angles, which are right angles, or just call it 4 right angles. Okay. Now, again, that could look like this because a rectangle can be a square, right? So both of those would be examples of rectangles. Put it together, a square is a rhombus meeting a rectangle. It has 4 congruent sides and 4 right angles. So you have to know that these are all the same and these are all the same in order for it to be a square. Okay, now there are going to come problems in your homework, in your quizzes, in your tests, where it's going to say, is this a rhombus, is it a rectangle, or is it a square? If I give you a picture that looks like this, and I mark nothing in it, can you tell me rhombus? No. Can you tell me rectangle? No. Can you tell me square? No. You only judge on the markings. You do not judge on what it looks like. You can't say, oh, well, it looks like a square, so that must be a square. You have to go based on like hard facts. I know all the angles are right angles. Okay, then it's if all the angles are right angles, a rectangle. That's as specific as you can go, right? Or if I say, I know all the sides are congruent, then it's a rhombus. Even if it looks like a rectangle or a square, you only go based on what you're seeing, okay? The information that they give you. Okay, so look here. Rhombus, rectangular, square. And here's the thing that it does not say. We are assuming all of these are parallelograms, okay? So this is a parallelogram. Is it a rhombus, a rectangle, a square, or can you not tell? If all I know is it's a parallelogram, okay, so we know this. Do I know rhombus, rectangle, or square here?
Yes.
How?
Rectangle.
How do you know it's a rectangle if they only marked one? Right, so lots of ways you can get there, right? Consecutives are supplementary or same side interior angles. Opposites are congruent. Okay, so we actually know all 4 when we only know one, right? All 4 angles have to be right angles because they told us it's a parallelogram. So this is a rectangle, right? It has 4 right angles. It's a rectangle. Look at letter B. What's the most specific name? Forget the A here. The most specific name you can give FGHJ.
Rhombus.
Tupu says square. Why? Consecutive angles are congruent. Okay, so we know, well, supplementary, but going to be congruent in this case. So we know that, right? We know 4 right angles. Do we know any other side lengths?
No. You know the opposite side length.
You know opposites are congruent, right? So opposite sides here are congruent. Oh, I took out a marking. So what is this?
Rectangle.
It's a rectangle, okay? It's tricky because, yes, you know one pair of opposites. Now, so this is a rectangle. What if I gave you this? That's a square, okay? This would be a square because now its consecutives are supplementary, opposite sides are congruent. That's a square. Okay, so be real careful with what markings they give you. Don't assume anything. Only go based on what we know. Okay, then there's a couple theorems that go along with this. Theorem 613, do not memorize the number. I don't care about 613. It's just chapter 6, the 13th theorem. What it says, I do care about. This one says the diagonals of a rhombus are blank. And I want to show you. Let's say this is our rhombus. Any insights as to what might be true about those diagonals? We know they bisect each other, okay, because it is a parallelogram, right? So we do know they bisect each other because everything about a parallelogram is true about this figure. Would you say, are they congruent? Are the diagonals congruent?
Yes. Yeah.
You think this length is the same as that length?
No. Not anymore.
They're not congruent. Does anything else appear to be true about them?
Perpendicular?
They're perpendicular. Yeah. The diagonals of a rhombus are perpendicular every time. Okay? That means these will be 90-degree angles in the middle, always, if it is a rhombus, right? These four are congruent. That's a rhombus. So your diagonals are perpendicular. And visually, like, you can see they're not congruent, right? So don't try to like make them congruent. They don't have to be congruent. They can be if it's a square. They don't have to be, okay? But they will always be perpendicular, the diagonals. Okay, so diagonals of a rhombus are perpendicular. That's one thing we know. The other thing we know is the diagonals of a rhombus do something to the angles they come in contact with. So this angle up here with this one here with this one here. Opposite angles are congruent in a parallelogram, right? The diagonal bisects, okay? The diagonals of a rhombus bisect a pair of opposite angles. So that's what I'm going to show you up here. I'm not going to redraw the picture. Maybe just draw an arrow to the one we already drew. We know this. This set of angles, these four, will all be the same. And the pink four will all be the same, okay? Opposites are congruent in the figure already. The diagonals cuts it in half. So you have 4 congruent angles and 4 congruent angles. That means in every rhombus that has the diagonals drawn in, how many different angle measures are there? 3 if you include the perpendicular, right? There's the perpendiculars, there's the black markings, and there's the pink markings, okay? Okay. Questions on that so far? Okay. I redrew this one, but I think after you already had your notes downloaded, does your picture look a little different than mine on A?
Yeah.
It doesn't?
It's like taller.
Yeah, it's not, it doesn't look like a rhombus in yours, right? These should be the same length. And in your picture, I don't think they look like the same length, which was a little bit confusing. So if you want to just redraw one that looks like a rhombus, great. Or just keep in mind, it should be sides that are the same length. Cut your other one down, however you want to do that. But it tells us this is a rhombus. Can you tell me the measure of angle 1? 100. A rhombus is a parallelogram, and opposite angles are congruent, right? So that's 100. how do you find 2 and 3?
Supplementary and then dividing in half of the bisect.
Okay, so that's one great way to do it. We know consecutive angles are supplementary, right? So if this is 100, then this whole thing is 80. And then you would cut it in half because it bisects the angles. Did anyone see it a different way? So this is 40 and 40.
I bet you could do, how do you call corresponding the x, the 2's in the top one and the 2 in the bottom?
You put the 2 here.
Yeah. I don't know
So,
what it's called.
that would be alternate interior, you could think of it as. Or I would just look at it like this. What kind of triangle is this? It's isosceles. And what do you know about isosceles triangles? Their base angles are congruent, right? So we know that these 4 angles are all congruent. So you could do 180 minus 100, leaves you with 80 degrees, cut that in half, and you get 40 and 40. And those are alternate interiors. There's a lot of ways to get there, but just keep in mind, all 4 of these angles will always be the same in a rhombus when the diagonal is drawn in, okay? It will bisect that angle. How about letter B? Can you tell me any of those angles?
2,
What is 2?
50,
Why is 250?
opposite interior.
Okay, so you can do alternate interiors, or we just learned a theorem that says what? The diagonals of a rhombus
Oh, one's 90.
bisect the angles, right? So that means all 4 of these are the same measure every time in a rhombus, okay? It also means all 4 of these are the same measure in a rhombus every single time. So 2 and 3 are what?
50.
2 and 3 are 50.
4 is 40.
Right, before that, 1 is what?
90.
1 is 90. The diagonals of a rhombus are perpendicular. So all 4 of these, only for a rhombus, okay? Not for just a general parallelogram. More specifically for a rhombus, makes that 90. Okay, so if this is 90 and this is 50, then you have 90, 50, and 4 that make a triangle. So that's going to be what? 40 degrees. A measure of angle 4 plus 90 plus 50 should add up to 180. Did you say that's so complicated?
No, it's just all coming together after we learned about.
Oh, I
we
know,
learned about
right?
the first time about triangle.
Isn't it beautiful?
Everything's
I-
coming.
Just all coming to fruition. How can you not love math, right? It's beautiful. It's God's perfect order. Okay, so that's rhombuses. Questions on rhombuses. Okay, I want you to keep this in mind. We've talked parallelograms, right? Big umbrella. So maybe you want to just, this is a parallelogram. Okay, that branches off to a rhombus. And a rectangle. This is where we're living today. That means everything that is true of the parallelogram is also true of a rhombus and a rectangle. Okay? So all the properties we've learned about parallelograms fit these 2 figures and the one that joins the 2, which is a what? Square. Okay, so there's this like trickle down effect, right? Everything at the top affects everything below it. Keep that in mind when we go through these. Okay, rectangles. We're going to talk about the diagonals of a rectangle. So look at this picture. Any guesses what might be true about the diagonals of a rectangle? They're congruent, okay? Here's the thing. we know that the diagonals of a parallelogram bisect each other, right? So these are the same and these are the same. But now, when it's a rectangle, they're all the same, right? The diagonals of a rectangle are congruent, okay? So yes, the diagonals are bisected, but more specifically, they're all the same length now. So we know that that's going to be our setup. So we would say like A, B, C, and D. Segment AC, the whole thing, is congruent to segment BD. Okay, the diagonals of a rectangle have to be congruent. Now, think about that for a minute for me. If our diagonals are congruent, I see 4 triangles. There's more than that. I'm just looking at the 4 that you can see with no overlap. What do you see about those 4 triangles? They're what? Not equilateral. Isosceles, right? So you have an isosceles triangle here, which means these are the same. You have the same isosceles triangle up here, which means these are the same. So all 4 of those angles are the same measure. Do you see any other angles that are all the same measure? The other set of triangles, right? These 4 will also all be the same, okay? You also have vertical angles and vertical angles. So there's a lot that you know just looking at a rectangle with its diagonals drawn in. Okay, keep that in mind. Use what you know to find what is missing. Okay, example 3 then. It says find the length of the diagonals of rectangle GFED if they tell you that FD is 2y plus 4 and GE is 6y minus 5. What do we do with that information?
Solve for y.
Solve for y, how? Set them equal, right? If the diagonals have to be congruent, then 2y plus 4 has to equal 6y minus 5. So solve that. Take away the 2y. Add the 5. So 4y equals 9. Divide by 4. So y is, you could call that 9/4. Or if you like decimals better, that would be 2.25. Like most of you would probably prefer that, because then what do we have to do with that information? Plug it in. We want to know the length of the diagonals. So we're going to take that, and you can plug it into either one because they should work out to the same thing. If I were you, I would plug it into both and make sure it does equal the same thing, and then you've checked your answer. But I'm not you. I'm going to plug it into this one. So FD is equal to 2 times 2.25 plus 4. What is that length? How's your mental math? 8.5. Okay, so FD is 8.5 and GE, if you plugged it in there, would also come out to 8.5. Está bien? See? Okay, what type of triangle is triangle HGD? Isosceles. If the diagonals are congruent and bisected, those are the same. This is isosceles. Lots of properties, huh? Okay, open up your Kahoot app or go to kahoot.it, and we're going to do a quick little Kahoot just to make sure we've got it. 764-4235. Use your name, please. Use your name.